This is page 3 of chapter 3. We've got another rational function. So let us start analyzing it. First thing I notice, the degrees in the numerator and the denominator are the same. What that means is that I can just take the coefficients on the numerator and the denominator, and that will be my horizontal asymptote. So there's a horizontal asymptote at y equals 6 over 2, which is 3. So let's draw in that horizontal line at y equals 3. Make it a dotted line because it's an asymptote. And I've already got something useful in this function. Alright, what else can I get from the function in the form it's in right now? Well, the negative 96 over negative 12 is going to be my y-intercept, because if I make x equal to 0, all of these terms will cancel out, and I'm left with negative 96 over negative 12, which is equal to negative 96 over negative 12. That's not right. Let's see. Clear. Negative 96 divided by 12 is 8. Okay, so coordinate of y-intercept is at 0, 8. Let's put a point in there, 0, 8. I've already got 2 points. How wonderful. Now, I can't really do much more with what I've got right now, but I can start to factor this. In the numerator I can factor out a 6. I'm left with x squared over, or minus 96 over 6, I believe is 16. On the denominator I've got 2x squared plus 5x minus 12. Well, 2x, maybe, let's try plus 3, and x minus 4. 2 times negative 4 gets me negative 8x, plus another 3x gets me positive, or negative 5x. So that's not right. I gotta change the signs on this. Make this an x plus 4 and an 2x minus 3. Now I've got positive 8x and negative 5x, or negative 3x, gets me positive 5x. That's what I need. So, the numerator is the difference of squares, x plus 4, x minus 4. The denominator is 2x minus 3, and x plus 4. This tells me a lot more about this function. For example, I notice that the x plus 4's cancel, which means that there is a hole at negative 4, comma, something. I gotta figure out what the y value is of that hole, so let's put it in. I can't put it into the original function because that x plus 4 is going to get me a 0, so I'll put it into my simplified function, which is 6 times x minus 4 over 2x minus 3. Of course, these two functions look exactly the same, except the one difference is that this one has a hole and this one does not. So I can evaluate at x equal to negative 4, because this function will be defined there, and I can see where that hole would have been. This gets me 6 times negative 8 over, let's see, negative 8 minus 3. That's equal to negative 48 over negative 11, which is 48/11ths. About 4 and a little bit. 4 and 4/11ths. So, let's put a point in at x is negative 4, y is up 4 and 4/11ths. And that right there will be a hole. Now, I get something else from this. I can see exactly where my x-intercept is. I've got an x-intercept at 4. That is when the numerator equals 0. So I've got the point 4, 0 in this. Let's put that in as a point. And the last thing I get is where my vertical asymptote is. It didn't cancel, so it's not a hole. It's got to be a vertical asymptote. 2x minus 3 equals 0. So 2x equals 3, and x equals 3 halves. So I will draw a vertical line at x equals 3 halves. That's 1.5 for people who aren't good with improper fractions. From here, I can pretty much draw the shape of my rational function. It's going to hug the asymptotes, jump through the hole, go through the y-intercept, go off there, then probably jump to the bottom, go through the x-intercept, and go off towards infinity. That right there is my final function. That's page 3 of chapter 3. I hope that it was helpful.